Okay, so this is linear regression part 2. So I want to go over a couple of vocab terms that you probably came across in the reading. So we have interpolate and extrapolate. So interpolate means you're just kind of looking inward inside what your domain is already. You're going to use the linear model or equation to predict a value within the given data. So for example, with this graph in number 7, if interpolate means we're going to kind of predict what's on this line here with that segment where the data falls within our domain. But the arrows we could actually extend out, and that's extrapolate. So when we are going on outside of the given data set, then we're going to do that. Obviously, if we have a specific point, that's different than not interpolate. Interpolate is we're saying like this, we're talking about like a point there on our line of best fit. So I'm going to write those definitions down and you can copy them. Okay, so I have 2 definitions here. Interpolate, and I highlighted in pink there the in. Use the linear model or equation to predict a value within the given data. Extrapolate, and I highlighted X, using the linear model to, or use the linear model to predict a value outside the given data set. Extend beyond, you can kind of think of it that way so that you can remember which goes with which one's which, okay? So hopefully that's helpful. Number 7, there is a close relationship between the air pressure inside a hurricane and its maximum sustained wind speed. Y equals negative 1.03x plus 1070, where x is the air pressure in millibars and y is the wind speed in knots, nautical miles per hour. So we have a graph here with wind speed on the side and air pressure along the horizontal axis. And we are asked a couple of questions here. Using the model, what would be the wind speed of a hurricane with air pressure of 935 kPa, whatever that is? Round your answers to the nearest knot. So it's knots for knots per air pressure or something like that. And so we're going to just take that value and plug it in for x into our function. And you are familiar with that. So go ahead and do that. And once we do that, tell me if that is extrapolating or interpolating. And you have to consider the domain of that. So the value we get is 106.95 knots, and that would be interpolate. Okay, so we interpolated. And we figure that out by looking at the 935 in comparison to our domain here of given data points. So it's within that. Number 8, the cost of a flight is related to the length of the flight by y equals 0.0849x plus 27.3, where x is distance in miles and y is cost in dollars. So here's our graph with distance along the horizontal axis. According to the model, how much would a 3,025-mile flight cost? Round your answer to the nearest dollars. So again, you're going to just plug in this value of 3,025 and then compare it to the domain of the given data set and tell me if you did, if you interpolated or extrapolated. All right, so we have plugged in the 3,025 in for x. We get approximately $284. That seems awfully cheap. And what we did was extrapolate because that's outside of our domain of the given data set. And that's really it for this video. Nice and short one with the applications. But I just wanted to keep the application examples separate. But remember to kind of read in the book too about the interpolate, extrapolate, that might help you in any of the other stuff. Go through, read the book, watch those additional videos giving you a broader scope, and then ask questions either online. You can interact and just send me a quick email or talk to me at some point in class. Have a great day.